So, hi Ani.
Hi Janakiraman.
Okay, so you wanted to do an experiment in order to demonstrate wireless transmission and reception.
Yes,
Right?
we did a wired transmission and reception.
Yeah.
This is the time to show them wireless as well.
Okay, okay. So, what are we going to do? Can you just sort of give
Sure.
a brief on the experimental setup?
Sure. So, what we are looking at, first of all, when we say wireless, we don't have any electrical connection between the two systems.
Okay.
So, what we'll do is we'll just assume that there are, we'll show the details. I'm just going to show at a very, very high level.
Yeah.
You have a transmitter which is TX. Okay.
Okay.
And the receiver which is RX.
RX. Right.
So, this is at a very high level. And really, so we are talking about wireless communication, right?
Yeah.
You know, wireless is actually of many types.
Okay.
Technically, what we call wireless today is normally, you know, radios, television, what you
Yeah.
receive on TV, over the air, cellular communication, and so on. But technically, wireless can be of many types,
Okay.
including your, you know, you're trying to control the TV using a remote,
Remote. Okay.
using an
yeah.
infrared signal. That is,
Okay.
you know,
Also some
that is
wireless.
also some kind of wireless.
Okay.
But maybe we'll start off with the traditional wireless communication.
yes.
So, what you need is you need some electronic circuitry
Yeah.
to create the signal
Yeah.
that you're going to send to the
Okay.
receiver.
Yeah.
So, one of the things that you require for a wireless communication is an element that I have drawn like this. This is the traditional representation of
Okay.
an element. This is actually called an antenna.
Okay. Right. I think this is what we saw in the radio, right?
We
pulled
saw in the
out a
radio, you
nice
pulled
long
out
one.
like a nice
Okay.
long
Yeah,
metallic antenna.
Yeah.
And even to receive, you need the exact same type of antenna
Yeah.
even to receive.
Okay.
So, you need the same electronic element there. So, unless you have this, you will not be able to transmit or receive efficiently.
Okay. So in a mobile phone, I don't see such long antennas. So that is like, you know, the antenna is more cleverly placed.
It's more cleverly placed, but there are two things.
Okay.
The size of the antenna
Oh.
is strongly related to something specific. It's related to the frequency at which you are
Right.
transmitting or receiving.
Okay.
Maybe we'll quickly look at that.
Yeah. Sure.
Right?
Yeah.
So, so the first thing to know, you are trying to, in what we call traditional wireless communication, you are sending information
Okay.
in the form of electromagnetic waves.
Okay.
You are sending information as electromagnetic waves. That is the
Okay.
first assumption.
Okay.
Now, even when you are doing remotes, infrared remotes, etc., technically that is also you are sending
Okay.
information as electromagnetic waves, but there is a fundamental difference.
Okay.
If you look at the wave nature, first of all,
Yeah.
automatically you are assuming, so this is sending the antenna converts an electrical signal
Okay.
to an electromagnetic wave.
Oh. Okay.
So, in a major part of this course, we have been talking about voltages, currents, you know, in the form of electrical
yeah.
signals.
Yes.
Now, the antenna is primarily required to convert the electrical signal
Okay.
to an electromagnetic signal.
Okay. Right.
And the minute you convert it to electromagnetic form, it becomes wireless.
It becomes wireless.
So, you send it as a EM wave.
EM wave. Okay. Right. So that's why it's basically available for everybody to now consume.
Yes. So, now one big difference between wired communication and wireless communication is that you are sending electromagnetic waves in free space.
In free space. Okay.
Yes. So, in fact, anybody can access that information.
So you're saying right now in this room,
Yes.
there is a lot of electromagnetic waves at different frequencies.
I can assure you of it. In fact, today,
Yeah.
I don't think you can go to many parts of the world where there is no electromagnetic wave.
Okay. So hopefully our experiment will also demonstrate all
Yes,
that.
we are going
right?
to
Okay.
demonstrate some experiments.
Okay.
But maybe what we will do, we'll get some idea of
Yeah.
what this electromagnetic wave.
Correct.
So the first thing we'll do is realize that if you have a wave,
Yeah.
I think everybody knows, they would have studied in high school physics, that the wave has a speed,
Yes.
a frequency and a
And a
wavelength.
Yeah, this we had done in week 3 when we did harmonics.
When you had done harmonics.
Yes, exactly.
Excellent.
Right.
So in this specific case, you are talking about an electromagnetic wave in free space.
Right.
So we will use the velocity as the speed of light,
Okay.
which is c,
Yes.
and we will say that let's say that the frequency is f
F.
and the wavelength is lambda.
So C equal to velocity is frequency.
Nu
times-
lambda is what you would have learnt in physics.
Exactly.
V is nu lambda
That's what we did for sound waves also.
for sound waves as
Correct.
well. So in this case, I'll write it because we have been using f as the variable for frequency. I will write it in this form.
Absolutely.
So this is the speed of light
Okay.
in the medium.
Yeah.
Right? We have to be very careful.
Okay.
In this specific case, the medium is air.
Air. Yeah.
Luckily, the speed of light is almost the same as that in vacuum.
Vacuum. So maybe what? That's like 3
That's
into 10 power 8
3 into 10 power 8 meters per
meter
second
per second. Okay.
in free space.
Yeah. Okay.
And f is the frequency.
Yeah.
And lambda is the wavelength.
So F is the frequency in the sense it's the frequency. Let's say the electrical signal that I wanted to send was A sin omega naught t.
Yes,
You're saying that frequency
absolutely.
is the F naught.
Exactly.
Right? Omega
So,
naught by 2 pi.
if you have a voltage V equals, in fact, I'll write it as 2 pi ft.
Yeah. 2 pi ft.
This is the frequency f.
F that we're talking about.
That's right. If you have a voltage or a current signal that is applied to the antenna, it gets converted into a plain electromagnetic wave of that frequency.
Of that frequency. Okay.
That's right.
Great.
So, in fact, one of the things that you have to deal with in electronics are sensors.
Yeah.
So, which convert we saw audio signal being converted
Correct.
to electrical
Mic.
form and vice versa.
Yeah. Mic speaker.
You can think of an antenna as a sensor which converts from electrical form to electromagnetic form,
or vice versa.
or vice versa.
Exactly. Right.
Right? And now lambda is the wavelength.
Yes.
And what we'll do, once we get a feel for what kind of frequencies we are talking
Yeah.
about, we'll do some calculations
Okay.
to figure out what the wavelength might be.
Okay.
Okay. So,
Great.
but before we go there, we need to look at something.
Okay.
So, I had said that we are transmitting information as an EM wave.
Yeah.
In free space.
Yeah.
And you also pointed out that there are EM waves around us.
Yeah.
So, in fact, already it means, so imagine that we are in a room and we are trying to talk to each other.
Yeah.
It is not possible for two sets of people to talk to each other unless they shout louder and louder,
Yeah.
and then nobody gets any information
Right.
across at all.
Right.
It's a shared medium.
Right.
So, it's a fundamental concept
Yeah.
that you are transmitting information in a shared medium.
Okay. Right.
So, this is fundamentally different from wired communication,
Right.
where so I am imagining I go let's say 150 years ago,
Yeah.
people were sending information on telegraph
Okay.
before wireless became common.
Yeah.
You used to have to run a set of wires, and even recently telephony, you used to have telephone wires,
Right.
right? You used to needed to have dedicated telephone wires or telegraph wires
Right.
run, and in fact this information on telegraph was actually binary,
Oh.
dots and dashes.
Right. Exactly.
Right. So you would have if multiple telegraphers tried to use the same set of lines, it wouldn't work.
It wouldn't work.
Right.
Right.
So now we have a problem. Imagine one person is trying to send. So let us say I'm going to say there are two users.
Yeah.
I'll say there are two users. In fact, two sets of users, let us say.
Yeah.
I'm going to draw stick figures
Right.
to represent people who are trying to talk to each other.
Yeah.
In fact, I'll show the other two on this side.
Yes.
It doesn't matter because I'll explain in a minute why it doesn't matter. So I'm going to show two sets of people.
Yeah.
And this person is trying to send a wave. I'm going to call that a message signal.
Yeah.
I'm going to say this is M1 of t.
Yeah.
Right. Let us say this is A1 sine 2 pi f1 t.
Yeah.
And this person is trying to receive it.
Yes.
And this person is trying to send another signal.
Yeah.
Which I'll call as A2 sine 2 pi f2t.
Yeah.
Now it turns out in many cases these antennas, unless you design it very carefully, they are not very directive.
Okay.
You're actually radiating out an all over space.
Okay.
So unfortunately, it is very hard. So most likely you are also radiating out M1 of t
towards the other
user who's trying to receive M2 of t.
Right.
In fact, this person is also sending
something here.
Right? This is M2 of t.
Yeah.
Okay. So in fact, I'll maybe call it beta M2 of t and alpha M1 of t.
Right.
So what the receivers receive is actually not just M1 of t that you wanted to send. They also receive M2 of t.
M2 of t.
Right. Now this is the problem because you are trying to. It's exactly the same situation as people trying to talk to each other.
Right.
So
okay.
Yes, this is actually a big problem.
Okay. Right. Okay. So I think in the radio we were looking at some concepts of frequency. Is this sort of related to that?
Absolutely.
Okay.
So the only easy way for them to not to be able to understand the message is to do two things. You have to do a combination of two things. So now this uses two concepts that we have already learned.
Okay.
So what you're going to do is, one possibility is to change. So let's say I choose F1 to be very different from F2.
Yeah.
Right. So this is like tuning a microphone to listen to a very, very specific audio signal.
Filter.
Clearly and that's number one. And you include that with a filter.
Yeah.
If you do this,
yes,
a combination of choosing the frequencies wide apart and good filtering will you'll be able to separate out.
You will be able to. I think right. So this theory we can look at maybe a little later. We will look at it, and understand it mathematically as well.
Absolutely.
Okay.
Yes.
Okay. So you're effectively saying, therefore, the transmitted signal has to be some sinusoid of some.
Has to be frequency, a sinusoid of
right?
some frequency. So
right?
that's why we will just say always that the general message form will be some A sine 2 pi ft.
Right.
Understand. So maybe we'll start with that. Shall we look at some theory?
Yeah, sure.
Yeah. Okay. So what we will do, let us look at a general sinusoid. So I said that m of t is some A sine 2 pi ft. In fact, I'll go one level higher and I'll say plus some theta. Right?
Right.
I want to send some information. This is just a sinusoid.
Yes.
Right. The information is actually contained in exactly 3 forms.
Okay.
Can you guess what they are?
Well, the sinusoid is characterized by 3 parameters.
Yes.
Amplitude, frequency, and phase.
Perfect. So you can actually send information on all of these.
Okay.
So a sinusoid by itself, if you actually want to change the information, you have to make some change in it.
Yes.
Otherwise, you just receive a sinusoid and that's it. There's no information.
Yeah, correct.
So now you can send information, let's say A of t.
Yeah.
So now you send the message in the form of an amplitude.
Okay.
You can send the message in the form of frequency.
Okay.
And in the form of phase.
Wow. Okay.
And these 3 have 3 different names. So this information sending when you send information via the amplitude, this is called amplitude modulation.
Okay.
So we will later plot
Yeah.
some of these and look at what they look like. So I am going to call this AM for amplitude modulation.
Oh, and this is what we saw in the radio.
Yes, absolutely.
We saw two bands, right? We
That's
saw
right.
AM and FM. FM was the other one.
Absolutely. So these are very old, very robust techniques of sending information.
Well before the mobile phones came.
Well before the mobiles came along.
Okay.
So this is amplitude modulation.
Yes.
This is frequency modulation. I'll call it FM.
Okay.
And this is phase modulation.
Right.
And this is PM.
Wow. Okay.
And in fact, if you see modern cellular communication or even wireless Wi-Fi,
Yeah.
Bluetooth, etc., they actually use a basic concept that is related to this.
This is okay.
Okay, so they send information via a combination of amplitude, frequency, and phase.
Right. I understand. Okay.